Hello, everybody. Welcome. 7.5, parametric equations. Here we are. So this is something that is going to take a second to adjust this section, but I think you'll like it. So you might want to be thinking, what is a parametric equation? And parametric equations are equations that show the position of the object horizontally and vertically. What you have dealt with to this point has been what we would call rectangular equations, meaning like y equals x squared plus 5x plus 6. That would be what's called a rectangular equation. But parametric shows specifically the horizontal and vertical parts of the equation. And they're typically set up as x equals 20t and y equals negative 16t squared plus 18. That might be something you would see. Okay. Uh, Now, what is a parameter? And you might be thinking, what is a t-value? Well, the t-value is the parameter in the parametric equations. Okay. We'll be giving you a list of t-values, and you will be asked to plot from there. Orientation. You'll be hearing me mention orientation some as well, and it's whenever you're plotting points of a parametric equations in the order of increasing values of t and traces a curve in a specific direction. So it's pretty much what is happening in your graph. So here's an example here. So we want t values from 0 to 8, including those values. And here are your parametric equation. We got x equals 3t and y equals square root of t plus 6. So when I put 0 in, x goes 0 and y goes to 6. You're just plugging them in. Put 1 in for t, you're going to get 3 for x, and you're going to get 7 for y. When you put 2 in, you're going to get 6 and root 2 plus 6. 3, you're going to get 9 and root 3 plus 6. 4, you're going to get 12 and 8. 5, you're going to get 15 and root 5 plus 6. 18, 21. I'm sorry I didn't have a box for this last one. 24. And we're going to get root 6 plus 6, root 7 plus 6, root 8 plus 6. So when we graph this, I'm at a quick coordinate plane here. When you do the same, the graph will look something like this, and most of it looks like it would be familiar, right? The one thing that you need to include are these arrows right there. Okay, not the arrow is true, but the arrows I'm pointing to right there, because that's going to tell you the orientation. As t increases, where is this graph going? Going in that direction. So we have write the following two equations in rectangular form, which is basically like we need to get rid of t's, okay? Eliminate the parameter. So in order to do that, let's get t by itself here. X plus 5 equals t squared, square root. We get square root of x plus 5 equals t. We're going to take that value and substitute it in for t in the other equation. So we get y equals 4 square root x plus 5. There's nothing to simplify. Next step would be to simplify, but it's nothing to simplify. You have eliminated the parameter. Congratulations. Next, let's eliminate the parameter again. So once again, and of course, the rest of the directions graph the equation, state any restrictions. I'm going to square both sides because we need to get t alone in the x equation. Subtract 4. Get x squared minus 4 equals t. And that's going to get me a rectangular form of y equals 1 over, and I substitute in for t, x squared minus 4. Now it says state any restrictions. So I'm looking here. my original. What and what is our range in our original is probably what you need to be thinking about. And that would be that x will never be greater than 0, right? Your output will never be greater than 0. Why? Because it's a square root function. Your square root function is always going to be 0 and greater. So right away, I'm going to state one of my restrictions as x greater than or equal to 0. Okay? Now I'm going to look at my end result, my rectangular equation right there. What do I see? You have a denominator, right, of x squared minus 4. What values can that not be? It can't be negative 2 and 2. Negative 2 we already said we can't do because we said of this right here. But we do not say that it can't be 0, which I need to do right now. X cannot be 0. So those are my restrictions. So let's get graphing. So 1, 2, and they're going to be 0, or not be 2 rather. And I'm going to graph this. And it would look just like it would if it was a 1 over x squared minus 4 equation. Now what about our orientation and everything? Let's a couple t's too. So if we would just label this like, we'll say that's whenever t is equal to 60, right? Because we'll call that's where x is equal to 8 and y is very small, right? So t is equal to 60. You can say up here somewhere, over here somewhere. T is equal to 12. At 12, what's happening? X is equal to 4, comma, 1 over 12, right? So what's happening as t increases? Well, your output is decreasing. So, and as we can see here, as t is increasing, it's going in this direction to the right. So I'll make some arrows right here. There you go. All right. So we got x equals 3 sine theta and y equals 8 cosine theta in rectangular form. So what we got to do in this problem is, in order to eliminate the parameter, we need to square both sides because we can't just get theta alone. So we're going to square both sides. This 9 sine squared theta, y squared equals 64. Wait, before we do that, let's try something else. Go away. To limit the parameter, it would probably be easier if we just divide by 3. Let's divide by 3 and 8. So we need x over 3 equals sine theta, and y over 8 equals cosine theta. Square both sides because I cannot get these by ourselves. So if we square both sides, we're going to get x squared over 9 equals sine squared theta, and y squared over 64 equals cosine squared. So let's add these terms together. That's going to, because we can't just get theta by itself. Even before, if we had inverse sine and inverse cosine, that'd be ugly. So what I'm going to do is I'm going to add them together. So what happens when I add them together? I get x squared over 9 plus y squared over 64. And what do we know about sine squared theta plus cosine squared theta? It equals 1. Doesn't this look familiar? So we got ourselves a little ellipse. So let's graph our ellipse. What would that look like? I'm not running out of space. I apologize. We'll call this 0, 8 up here and 0, negative 8 down there. 3, 3, and it's a very tame ellipse. So arrows are going in this direction all the way around. Why? Because as theta increases, that's where the direction's going. Okay. appreciate you. Thank you. And we'll see you in class. Bye bye now.